Hi, this is Rich Evans. I'm going to explain today how to solve a literal equation for a specific variable. A literal equation is just an equation that has two or more variables in it. A lot of times people will call that same thing a formula. And we're trying to manipulate the formula to get a particular variable by itself on one side of the equation. So in number one, we are told to take the equation a equals p plus prt and solve it for r. Now that means to try to get the variable r to be all alone. Right now the r is right there in that term prt. Always the first step is to get the entire term to be alone, which would be the whole prt. So you can do that by subtracting p from both sides. So if you subtract p from both sides of the equation, you would have a minus p equals PRT. Now that you've done that, you can divide both sides of the equation by PT to get the R to be alone. So you divide both sides by PT. The P and the T cancel out, leaving you behind with the R, which is what you want. So your final answer would be R equals A minus P divided by PT. Okay, let's look at the next example. We're trying to take the equation y equals mx plus b, which is the equation of a line, and solve it for m, meaning get m alone. Now before we can get m alone, we have to get the whole term mx to be alone. So we need to eliminate the plus b on there. We'll do that by subtracting b from both sides. That gives us y minus b equals mx. Now to get to m alone, since it's being multiplied times x right now, we have to divide both sides by x. That makes the x's cancel out, and it leaves us with the m, which is what we want. So m equals y minus b divided by x. In the next example, we have ax plus by equals c, and we're trying to solve for x. So first we isolate the term that has the x in it, which is ax. So we'll subtract the by from both sides of the equation. That means they'll cancel out over here and just give us ax. And on the right side we'll have c minus by. And then to get the x alone, we'll divide by a on both sides of our equation. Notice when we divide the right side of the equation by a, we have to divide the entire side of the equation. So the fraction bar has to go all the way across. So we end up with x equals c minus by divided by a. In this next one, this is actually the formula that you convert from Fahrenheit over to Celsius with for temperatures. We're trying to get the F to be alone. Now, there's a couple different ways you can go about this, but one way you can do it is to eliminate this fraction in front of the parentheses, 5/9. And the way you can eliminate that is to multiply by the reciprocal, which would be 9/5, because 9/5 times 5/9 just is 1. So it would really be non-existent there, because 1 times anything is itself. So we're going to multiply both sides of the equation by 9/5. So 9/5 c equals 9/5 times 5/9 times f minus 32. Now again, the 9/5 times the 5/9 is really just 1. And 1 times f minus 32 is just f minus 32. So we really just have 9/5 c equals f minus 32. Then it's very simple to get the f to be alone. All you do is add 32 to both sides of the equation. and we get 9/5 c plus 32 equals f. And that would be your answer. I usually like to switch it around and put the f on the left side, but this time I'm not going to bother doing that. Now, the next set of problems are going to require factoring in order to solve for the indicated variable. These first examples that we did up above here, we didn't have to factor in any of those. And if you see, you know, in the instructions, these are literal equations that do not require factoring. Now we're going to get into ones that do require factoring. They're a little trickier. Now, the reason why they're going to require factoring is because the variable you're trying to solve for occurs in more than one place in the equation. For example, in number 1, we're trying to solve for pi. But pi is in here in 2 pi rh, but it's also over here in 2 pi r squared. So the only way you can kind of get those two pi's together into one is to factor it out as a common factor. So what we would do in this one is we'd first start by factoring pi out of the right side of the equation, treating it like a common factor. So we put it in front of a set of parentheses, and then you'd have 2r squared plus 2rh. Once you've done that, since the pi is getting multiplied times this whole set of parentheses, you can get the pi alone by dividing both sides of the equation by the entire set of parentheses. So we can divide both sides of this equation by the whole expression that's inside the parentheses. That makes that entire expression cancel out, and it just leaves us with pi, which is what we want. So the answer here would be pi equals a over 2r squared plus 2rh. Okay, moving on to this next one, it's going to be a similar idea. I'm going to start here by just distributing this 2 through the parentheses. So we have s equals 2lw plus 2lh plus 2hw. Now we're trying to solve for h. You can see that right here. And the h is occurring right there and right there. So the terms that have h in them are 2lh and 2hw. Those are the two terms that contain h, the variable we're solving for. This first term here, 2lw, doesn't have the h in it, and neither does the s on the other side of the equation. So what you want to do is you want to get the two terms, or might not be two, but get all the terms that have the variable you're trying to solve for on one side of the equation, and get all the other terms that don't have the variable you're solving for on the opposite side of the equation. So what we'll want to do here is subtract this 2lw from both sides. That's going to give us s minus 2lw equals 2lh plus 2hw. Notice the two terms that have h in them are on the right, and the two terms that don't have the h in them are on the left. And that's exactly how we want it. Once we've done this, we want to take that variable we're solving for, which is h, and factor it out as a common factor, which gives us h times 2l plus 2w on the right side. And the left side would still be the same, s minus 2lw. Lastly, again, since this h is being multiplied by this whole set of parentheses, we can get the h alone by dividing both sides of the equation by the entire expression that's inside that parentheses. which is 2L plus 2H. Or, I'm sorry, 2L plus 2W. That cancels out now on the right side, leaves us with only the H. So our final answer would be H equals S minus 2LW over 2L plus 2W. Now this next example adds another twist because there's fractions involved. And usually when there's fractions involved, we want to get rid of the fractions. And one of the ways you can get rid of the fractions is to get a common denominator in all the fractions in every single term in the equation. Alright, so let's start by doing that. The common denominator would be FAB. So in this first fraction, 1 over F, we'll multiply both the top and the bottom of that by AB, which would give us AB over ABF. Then we have an equal sign. Now in this next term, 1 over A, we're going to have to multiply, remember we want to get ABF as the denominator, and we already have the A. So what we're missing is the B and the F. So we'll multiply the top and the bottom by BF. That gives us BF over ABF. And then we have a plus. And then for this last term, we're still trying to get ABF as the denominator. We already have the B, so we're missing the A and the F. So we'll multiply the top and the bottom by AF, which would be AF over ABF. Now notice I've rewritten this equation so that there's a common denominator all the way across the whole equation. Whenever you can do that, you're allowed to just eliminate the denominators. And the reason is because this is an equation. See this equal sign here? And so you can multiply both sides of the equation by the same thing. And if you multiply both sides of the equation by ABF, it's going to make it cancel out all the way across. So what we really end up with is AB equals BF plus AF. Now, what are we trying to solve for in this problem? We're trying to solve for B. So we want to get all the terms that have B in them on one side and all the terms that don't have B in them on the other. We want it separated. So if we look through this, this term has B in it, and so does that one, and this one doesn't. So really you'd like to get this term BF over to the left side of the equation. So we'll subtract BF from both sides. That gives us AB minus BF equals AF. Now we can factor out the B as we did before as a common factor, which leaves us with A minus F in parentheses, and then divide both sides of the equation by the expression A minus F, which leaves us with a final answer of B equals AF over A minus F. Okay. Next example, we have a fraction, 1/2 in it. It'd be nice to get rid of that. So I'm going to start by multiplying both sides of the equation by that denominator 2. So that means I have to multiply every single term. There's 3 terms. There's the E, there's the MGH, and then there's the 1/2 mv squared. And all 3 terms would have to be multiplied by 2. So I have 2E, I have 2 MGH, and in the third one I have 2 times 1/2, which they cancel out and just give me mv squared. So notice that got rid of the fraction, which makes it easier to deal with. Now in this case I'm trying to solve for m, so I have to check to make sure all the terms that have m in them are on one side and the ones that don't are on the other. Actually, I got kind of lucky this time because the two terms that have m in them are already on the right side, and the one term that doesn't have m in it is already on the left side. So it's already set up just right. So we're going to factor out the m from the right side of the equation, which leaves us with 2gh plus v squared, and then divide both sides by the expression inside the parentheses, 2gh plus v squared. And that gives us our final answer, which would be m equals 2e over 2gh plus v squared. In this next problem, I'm going to use the strategy we used in a previous example. Since this is really 2 over 1, I'm going to try to get a common denominator in all three fractions. The common denominator would be bx. So to get a bx in the denominator of the first fraction, you'd have to multiply the top and the bottom by x. So you'd get x over xb. In the second fraction, to get a bx in the denominator, you'd have to multiply the top and the bottom by b, which would give you 2b squared over xb. And in the third fraction, you'd have to multiply the top and the bottom by xb, which will give you 2xb over xb. Now again, since this is an equation, it's really important that it is an equation, you can multiply both sides of the equation by xb, and that's going to make all the denominators cancel out. If it weren't an equation, if there was no equal sign, you wouldn't be able to do that. So we now have x plus 2b squared equals 2xb. Now we're trying to solve for x. That means we want to get the two terms that have x in them on the same side of the equation, and the one term that doesn't have x, which is the 2b squared, we want it on the other. So the easiest way to get those separated is to move the x over to the right side of the equation by subtracting it from both sides. That gives us 2b squared equals 2xb minus x. Now we can factor out the x just like we've done in the other problems, which gives us 2b minus 1. Still have a 2b squared over here. And then we divide by the expression in the parentheses, 2b minus 1, on both sides. And our final answer would be x equals 2b squared over 2b minus 1. Okay, we're on our last problem now. This one is another one that involves a fraction. I'm going to deal with it slightly differently this time. This is really s over 1, and then that's equal to another fraction. So it's of the form a over b equals c over d. One fraction is equal to another fraction. And that's called a proportion. That's a special type of an equation. And whenever you have a proportion like that, usually the easiest way of eliminating the fractions is doing what we call cross multiply. So to cross multiply in this one, we would multiply the 1 times the a minus rl, which is just a minus rl, because 1 times anything is itself, and that would be equal to s times 1 minus r. And you'll have to distribute that through, so that would really be s minus SR. Okay, now that we've done that, it becomes a little easier problem. Now we're trying to solve for R. So the two terms that have the R in them, we want to get those on the same side. And the two terms that don't have R, we want to get those on the other side. So it's not in the right form right now. We have to put it into the right form. So what I'm going to do is I'm going to move the S over to this side and the RL over to this one. And the way we can do that is we can subtract S from both sides. I'll do it in 2 steps. So that gives us A minus RL minus S equals negative SR. And then we can add RL to both sides. And that would give us A minus S equals negative SR plus RL. Now that we've done that, we can factor the R out, which leaves us with negative S plus L, and divide through by that set of parentheses. That gives us a final answer of R equals A minus S over, and it would be negative S plus L. Now you could write the L first and the minus S second, which I think looks a little nicer. So it would be L minus S. So I hope that helps you understand how to solve literal equations, especially in those cases where it requires factoring.